Thank you all for being here. So in this profession, you end up giving a lot of talks, and I lost count years ago of how many I had given. But it occurs to me this is the very first public lecture that I've given, and it's nice to have a lot of people in the audience. I realize that's because I have a great following act, but and since we want to get to that, so Harold and Maude. So Harold and Maude is a movie about, for those of you who don't already know, two people who refuse to act their age. So you have Harold, who spends most of the movie telegraphing his disdain for all the things that you might think that a 20-year-old would be interested in. Fancy cars, friends, girls. What he seems to be mostly interested in is his favorite pastime is attending funerals, which is an odd pastime for someone who actually doesn't know anyone who's died recently. In contrast, Maude is a free spirit, constantly in a sort of obsessive quest for new experiences, and completely uninterested in societal convention. So actually, the characters from the play Hair, which was, when this movie came out, in 1971, Hair was still on Broadway in its first run. The characters from Hair would have found her completely relatable, except for, of course, the fact that she's 79 years old. So the reason I was asked, as you heard a little bit, to talk about, to introduce this movie is I study really lifespan development from early development through sort of adulthood, middle age, and old age. And it turns out that we actually don't, so I'm going to tell you some of the stuff that we've learned recently, and at the end of this, hopefully, if I've done my job right, you will know less than you know right now. Or at least less than you think you know, because it turns out, especially in the last few years, we found that development and aging is a lot more complicated, a lot more variable, and a lot harder to predict than you might have thought. And so there's a lot of research going on, a lot of great progress in the last few years, I'm sure over the next few years, but at the moment, scientifically speaking, it's not really clear what it means to act your age. So I guess that's something you're just going to all have to figure out for yourselves, which is a lesson that I think Maude would appreciate. So most people have probably a naive idea that development looks something like this, or rather, you go through some period in which you are developing and becoming bigger and better at things, and then you have a period when you're at the prime of your life and sort of as good as you're going to be at anything, and then there's this other period that comes after that. And you certainly can find data that match this. So here's actually the very first study I did on lifespan development. It was on short-term memory. And this is sort of what it looks like. So again, from about 10 to 70 years old. One thing though, so you might take from this that probably a lot of people are taking from this, oh God, it's not going to get any better at this point. But graphs like these actually obscure a lot of very important things about how we change over our lifespan. One thing actually is that, and this is true of pretty much every graph you'll ever see, I've zeroed in on where the interesting changes are happening. This is actually, this memory test is a 42-question test, so there's 43 possible scores. Oh, by the way, I've scored this like basically an IQ test where 100 is average. 60-some% of people will fall between 85 and 115 on the scale. But there's 43 possible scores you could have gotten, and if you look at the full range of possible scores, this is what the graph would look like, from 25 to 130. And of course, these are average. What I've actually graphed here are averages, and you can see actually the average isn't changing that much. And then if you look at variability across people, so here's the scatter plot of the actual people who took this test. And there's actually about 20,000 people here. It's just because there's only 43 possible scores, most of the dots overlap, as you might imagine. But it really means pretty much any given age, you may be better than people who are, according to the average, were supposed to be better than you. You may be worse than people who, given the averages, are supposed to be better. Yeah. Anyway, you got the idea. So the standard model of development is missing a number of things. One of the things is just variation across people. Again, to give sort of an example of that, it is also true physically that we tend to decline, really starting by our mid-30s. I'm in my mid-30s. Tom Brady and David Ortiz are older than that, so obviously they're less athletic than I am. Another thing that it's missing is variation across abilities. So it turns out that that graph that I showed you for short-term memory is not the same graph that you see for just anything that you might measure. So actually, as I said, this was the first one of these studies that I ran. And I was presenting it, I was maybe a second or third year graduate student. As I was presenting this, one of the senior faculty members raised her hand and said that that was all very nice and impressive data, but could I show her the curve for wisdom? And it's funny, but it actually turns out there is a curve for wisdom, depending on how exactly you define wisdom. But if you think wisdom is, some amount of knowledge that you have accumulated because of your experience, we actually can measure that. It turns out people have been measuring it for a long time. It generally goes under the term crystallized intelligence. IQ is often divided into two components: fluid intelligence, crystallizes this essentially wisdom. And one of the best measures of crystallized intelligence or wisdom is actually vocabulary. It predicts, basically, people who know more words know more of just about anything you might want to measure, which kind of makes sense, because how do you learn words in the first place? Well, you learned about something, and then you learned vocabulary that was necessary for that something, whatever it is. So here is what that looks like. Yeah, okay, so you're probably not going to clap about the next one. So the next one's is processing speeds. This is also usually one of the subtests of the IQ test. Measures just like how fast you can think on your feet. So if you are under 18 years old, congratulations, you still have some progress to make there. And then, of course, now I've just been talking about intelligence. What about emotional intelligence or social intelligence? So one of the oldest tests of social intelligence is essentially an emotion perception test. So you see pictures of people and trying to say, what are they feeling right now? And every test that I've run of social intelligence shows this green pattern here with basically rapid improvement through the teens, continued improvement until about the mid-40s, and then a long plateau, and then maybe a little bit of decline, but not much relative to what we see for other things. And by the way, blue here is short-term memory, but actually it turns out the curves you see depend on what kind of memory even you're asking about. So if we're looking at sort of your ability to quickly memorize something, say faces or somebody's face that you just met or their name, that actually shows different patterns. So people are best at learning new names at around 22 years old. Faces, you hit peak a little bit later than that, about 32 years old. And I've been talking about thinking ability mostly because, A, that's what I know best, that's what I actually study. And also, I think it's the area that there's been the most study of, so I had the most graphs to show you. But people have been able to study how other aspects of you change over your lifespan. So actually, I don't know very much about the working memory or the short-term memory or emotion perception abilities of Harold and Maude, but we learn a lot about their personalities. So how does personality change across the lifespan? So there's a number of different aspects of personality. Here's extroversion. Apparently, people become steadily more introverted as they get older. The reason there are two lines here is it's two different data sets, but they both show more or less the same pattern. This is not my data. I have the names of people who did it down there. Neuroticism also declines. So there's a little bit of disagreement between these two data sets is in terms of how fast it declines, and there's something weird going on in sort of the 70-80 range there, but generally, people get less neurotic, and they become more agreeable, it turns out. Again, these are all averages. This doesn't mean you are getting more agreeable. You might not be. I can only talk about the average person in this room. conscientiousness does something very different, which is interesting. So people in their 30s and 40s are conscientious, and then they decide they don't want to be anymore. Again, except for something going on in the 70s and 80s there. I haven't looked carefully at this data set. Usually we see a lot more noise in the older population, which might make sense both because of medical reasons and also there are generally fewer of them in these studies. It's harder to recruit older people for reasons you can probably guess. And so the weirdest curve that I've seen so far, and again, this is not my work, and I'm sorry I didn't put the names of the people who did it on this slide, but this is self-esteem. Red is men, and blue is women. So men apparently have more self-esteem. And again, you see this interesting, like, precipitous drop through the teens. Some people probably remember that. And then it recovers a little bit, and then plateaus sort of in early adulthood, and then, of course, you see sometime in the 40s, it starts to pick up again. And then for men, at least, recovers to its original height. Not for women on average, but again, this is going to be different from person to person. So variation across people, variation across sort of abilities or aspects of personality. There's also, interestingly, variation across culture in terms of what happens with aging. And the most fascinating data sets, I think, actually look at the same culture-ish over time. So if we're just looking at just America, things have been changing in terms of how we age. So everybody remembers the best graph that I had. It was everyone's favorite, where you kept on getting better and better in vocabulary. If I had given this talk 40 years ago, you wouldn't have liked the graph as much because it looks like this. So I was able to pull this out of a historical archive. There aren't a lot of these old historical archives, but there's a few. There's one vocabulary test that the General Social Surveys has been giving forever. So if you look at people who took that test between late mid-70s to mid-80s, the peak was clearly at around 40 years old, and then people's vocabularies got smaller for some reason. You look the following decade, and the peak's now a little bit later, so not quite 50 years old is where the absolute peak is. These things always look noisy. We have various ways of dealing with the noise for these analyses. If you look at the late 90s through about 2012, you see something that looks a lot more like what I showed you, with a peak at around 60 years old. If you actually have very good visual memory, so I guess that'd be the people between about 25 and 35. You might actually remember the graph I showed you from data that I collected in 2013-14 that I originally showed you actually shows a slightly later peak than this does. So what's going on? So apparently we're learning more words later into life and starting to forget them later than we used to. This is probably related to the Flynn Effect, which is discovered by James Flynn, a sociologist, and probably the Flynn Effect's the most important scientific discovery of the last 50 years that you probably haven't heard of. Surprising number of people haven't heard of it, and the effect is that IQ scores have been going up for as far back as we can measure. The way this was discovered was accidentally. It turns out that every so often, IQ test manufacturers have to update the test because people are doing too well, and the average is, as I told you before, supposed to be 100, and suddenly the average is 108, 109, and they have to fix the test to make it harder. And they've been doing this for now over 100 years. And so if you backtrack and figure out, all right, well, if we went back 100 years ago, in 1915, and gave a bunch of Americans an IQ test, how would they score? Well, this is just simulated data here, but this is the familiar bell curve. This is what an IQ test is supposed to look like. If I gave an IQ test right now to all of you, then this is probably what we would see. Nah, probably not. This is Brookline, but probably be a little bit skewed. But in theory, this is what we should see for the population. Again, 100 is average. About 60-some% will be between 85 and 115. Around 95% of people will be between 70 and 130. Usually 70 is the cutoff for an intellectual impairment or disability. 130 is often the cutoff for placing people into gifted programs, though it depends by school district. So now what would happen if we went back to 1915 and gave people IQ tests? This is what it would look like. With an average of around 70, which I just told you is the cutoff for intellectual disability or impairment. Going out on a limb, I don't think that 100 years ago the average person was what we would now consider having intellectual impairment. So what's going on? It turns out that there's specific aspects of the IQ that have been getting better over time, and it's especially stuff that's related to our ability to reason analytically. That has been improving. Memory, for instance, has not been improving nearly so much. And when you think about it, this might make sense if you actually follow what's happened over the last 100 years as we've moved from a society where most people are involved in agricultural labor to then moving into industry, and then finally now we're largely a service economy with a lot of people who have to essentially engage in analytical reasoning, and specifically the type of analytical reasoning that is picked up in IQ tests. It turns out that a bunch of scientists invented the IQ test, so when they decided what counts as being intelligent, they thought it was the stuff that you needed to do to be a good scientist. And the world has become more scientific over time, and so people are testing as better scientists now. That's, again, not a value statement. You might think that it would have been better if we were all better farmers, but in any case, in terms of what the IQ test measures, this is what is happening. But here's what I get out of this that I think is interesting, which is all those graphs that I showed you earlier in terms of, what age people tend to peak for different kinds of activities. We know for at least some kinds of activities, that's not fixed in stone. That's malleable based on society. Oh, by the way, some of you might be wondering, well, is it just better nutrition? It turns out nutrition can't explain the increase in IQ alone. Probably doesn't explain the increase in vocabulary either that I showed you. So again, in general, our sort of standard understanding of how development and aging works is probably wrong. If it makes sense to talk about somebody being in their prime, you have to ask prime for what and when. Is this being in their prime for vocabulary now, or is it in the past? Are we talking about being at your prime in terms of having low neuroticism? It's going to depend. And this, again, I think is why it's important, obviously, to think about the individual rather than averages. If we were just to go by the average 20-year-old or 79-year-old, we would not know who Harold and Maude are. And that's not just true for them, it's probably true for most of us. And I'm mostly finishing right there. I'm about to watch the movie, but I did want to point out, if you're interested in some of this work, a lot of the data that I showed you, both my own data and other people's data, was collected online. This is one of the nice things about having laboratories online these days, is pretty much anybody can participate if they want to. So you can go to my website, gameswithwords.org, do some of these experiments, read about some of the past results. Testmybrain.org is one of my other favorite ones that you can check out. And but in the meantime, let's watch the movie.